Hello students, welcome to crash course of KEAM 2023. We are preparing for KEAM Maths, Physics and Chemistry on this particular channel, that is Vedantu Malayalam channel, where you will get lectures of each and every chapter with complete revision of all the topics, solving previous year questions of each and every topic to give you an idea what type of question will come in your exam, mind map of the entire chapter and formula cheat sheet of the entire chapter to help you revise it in just 2 pages before your exams. Okay, so this is a complete lecture which will help you prepare application of derivatives, a very important chapter, because every year at least 5 to 6 questions will be there from this particular chapter itself. Okay, so I'm Sana Khan, your maths master teacher from Vedantu, and you are watching Vedantu Malayalam channel KEAM Crash Course. So let's begin the class with the introduction of the topics that we are going to learn today. So I will help you revise rate of change of bodies, increasing decreasing function, maxima and minima, tangent and normal. Direct questions are asked from all these topics. Never you will see any indirect question from these topics. Okay, so they are pretty basic, pretty simple. You have to solve them in only one way. I will show you multiple type of previous year questions also to give you an idea how the questions will come. Alright, so let's get started with the first topic, rate of change of bodies. So basically, what is rate of change? So it is like when a certain quantity is changing with respect to something. For example, speed changing with respect to time, distance changing with respect to speed. So something changing with respect to something. Now how do we calculate that? We calculate that using the derivative of that function, basically of the depending function with respect to the independent function. So for example, if we say that y is a quantity that is changing with respect to x, that is another quantity, then we say that y is a function of x and we calculate the rate of change as dy by dx, which will be f dash of x. Okay, for example, if I say that my speed, y is the speed, it is a function of, or you let me say that here y is the distance and it is a function of speed, x square plus 5, this is speed. So when your speed will change, your distance traveled will change, right? Now if you want to calculate how much distance has changed, how much distance have you traveled, you will simply find derivative of this function. Okay, now sometimes what happens, your function may be not directly linked, they might be indirectly linked. How is that? Suppose your speed is related to time and distance is also changing with respect to time. Now you want to find out how speed is changing with respect to distance. So how you will do that? Simply, suppose that speed is a function of time, ft, distance is also a function of time, ft. Now first we will find out what? We will find out dx by dt, like how the speed is changing with respect to time. Then we will find out dy by dt, how distance is changing with respect to time. And then we can find out dx upon dy. How? Just divide dx by dt divided by dy by dt. When you divide these two values, dt gets cancelled, you get dx upon dy. Now if you want dy by dx, just do reciprocal. If you do reciprocal, you will get dy by dx. That is how distance is changing with respect to speed. So anything can be found out. Okay, let me share a very simple example with you. Okay, find the rate of change of area of a circle per second with respect to its radius when radius is 5 centimeter. Now they are saying that area of a circle is pi r square, where r is the radius of the circle. Now they are asking rate of change of area. So dA by dr. So they are asking rate of change of area with respect to, see it is written with respect to radius. with respect to radius. So dA by dr. So what will be dA by dr? Just differentiate this with respect to r. So pi will remain pi. R square will become 2 times of r. So this is 2 pi r. Now they are asking rate of change at r is equal to 5. When r is equal to 5. So just put the value of r as 5. So you get 2 pi into 5. So the answer is 10 pi. How simple it is, see? How simple it is. Such type of question can come in your exam. That rate of change of area with respect to radius. So first you write the formula of area and radius, how they are interlinked. Then you differentiate it. Then you put the value of radius, whatever is given in the question. That's it. That's all you have to do. Okay. Next topic is increasing and decreasing functions. Question are directly asked from this topic also. Now, first you should understand what is an increasing function and what is a decreasing function. So increasing function means if you take two values, for example, if you are taking a value x1 which is less than x2, then for these two values f of x1 is less than f of x2. That means if suppose you are taking x1 as 1 and you are taking x2 as 2 and you are getting f of x1 here and f of x2 here. So clearly you can see that this is greater than this. F of x2 is greater than f of x1. Clear? Now similarly, what will be a decreasing function? The graph looks like this. It is going down. It means what? If a value x1 is greater than x2, this implies that your function at that point is less than the function at the other point. That means if x1 is greater than x2, it means f of x1 is less than f of x2. Observe this graph, you will understand. X1 is here, x2 is here. Now x1 is greater than x2, but you see f of x1 and this will be, sorry, here the example I am taking is x1 is less than x2. Suppose this is 1 and suppose this is 2. But if you observe f of x1 is greater than f of x2, opposite will happen. Okay. Now similarly you have non-decreasing and non-increasing graph. Now what does that mean? Non-increasing means it is either decreasing or constant. That means it is not changing. For example, this graph, it is decreasing, constant, decreasing, then maybe constant. Constant means horizontal like this. It is not going down, it is not going up, it is just horizontal. Now similarly, non-decreasing means it is either increasing or constant. Now how the graph will look like, you understood? Okay. Now this is like a simple generic question. I will also show you previous year question paper question. Show that this function is increasing on R. Now, how can you represent that this function is an increasing function? Assume any value. Okay, just assume any value. Suppose I am taking x1 as 1 and I am taking x2 as 2. You find out f of x1. Now see, x1 is 1, x2 is 2. This implies that x1 is less than x2, right? Now, what is f of x1? F of x1 will be put x is equal to 1. So, 3 into 1 plus 17. Similarly, f of x2 will be 3 into 2 plus 17. So, 3 plus 17, 6 plus 17. 3 plus 17 is 20, 6 plus 17 is 23. So this is greater than this. This implies that f of x1 is less than f of x2. Hence, you can prove when x1 is less than x2, we are getting f of x1 less than f of x2. That means it is an increasing function. Same is happening. Less than is happening. If less than, greater than happens, decreasing function. Okay. Now, that type of question will not come in your exam. Mainly, in the exam, they will ask you check if it is increasing, decreasing, neither increasing nor decreasing, or they will ask you find the interval in which the function is increasing or decreasing. How you do that? For that, there is a method. That method is first order derivative. That means you have to find out f dash of x to check if fx is increasing. It will be increasing if f dash of x is greater than 0. It will be decreasing if f dash of x is less than 0. Simply. Okay. It will be non-decreasing if f dash of x. Non-decreasing means increasing or constant. So f dash of x is greater than 0 or f dash of x is equal to 0. Non-increasing, f dash of x is less than 0 or f dash of x is equal to 0. Like either this or this happens, then non-decreasing. But if sure short it is less only, then decreasing function. Okay. Now, let me show you some previous year questions asked in the KEAM exam of this particular topic. Okay. This is a function fx. Find it is increasing on which interval, from where to where it is increasing. You have to find that. Step number 1, you have f of x is equal to x cube into e to the power x. You will find out f dash of x. F dash of x is you derive it. How you derive it? Just before this chapter, I have taught you continuity and differentiability. There I have taught you product rule. If two functions are multiplied, how you derive them? First, derive this. Now, it will be basically d by dx of x cube into e to the power x plus d by dx of e to the power x into x cube, like this. Now, how you derive x cube? 3x square into e to the power x plus differentiation of e to the power x is e to the power x into x cube. Got it? Now, to find out it is increasing or decreasing in which interval, first we should know what are the interval points. To get the interval points, you have to equate this to 0. Okay? I am telling you step by step what you have to do. So first you equate it to 0. So suppose I take out e to the power x common and I take out x square as common. I get x plus 3 equals to 0. This implies that x is equal to minus 3, right? X will be minus 3. So you have two intervals. Just check here. One interval is minus 3 to infinity, other interval is minus infinity to minus 3. Now you have to find out in which interval it is increasing and it is decreasing. How you will do that? Now you come back to this f dash of x. What is f dash of x? E to the power x, x square, x plus 3. Now you observe here. If you put value greater than minus 3, suppose you are putting minus 2. Minus 2 is greater than minus 3, not smaller than minus 3, okay? If you put minus 2, what will you get? Just find e to the power minus 2, x to the power, not x to the power minus 2, sorry. Minus 2 to the power 2 and minus 2 plus 3. If you solve this, basically you will get greater than 0. It's a positive function, right? Wait, let me do it in the next page itself. I will show you. Suppose we have f dash of x as x square e to the power x, x plus 3. Okay, we want to check two values. One value which is greater than minus 3 and another value which is less than minus 3. So we will check minus 4 and we will check minus 2. So f dash at point minus 2 is minus 2 whole square e to the power minus 2 and minus 2 plus 3. Now this is plus 4, this is upon e square, and this is 3 minus 2, 1. Is this answer positive? 4 upon e square is definitely a positive number. 4 upon e square is a positive number. So it is greater than 0. If it is greater than 0, it is increasing function. So no need to check for other interval. We can directly say that for any value greater than minus 3, my function is increasing. So the answer is minus 3 to infinity, my function is increasing because I checked. Okay. Similarly, another KEAM PYQ. I think this question was there in 2019 question paper. This function is decreasing on which interval? Again, very similar type of question. So, majorly from this chapter, you will see very similar question asked every year. So, it's very good chapter. If you prepare it, short, you can solve the question. 100% you will be able to solve the question. Okay. Now the function is given, so we will find f dash of x. Again, product rule. This is first function, this is second function. So d by dx of first function into second function plus derivation of second function into first function. This is what we do. So we have 2x e to the power x plus e to the power x into x square minus 3. Now we take out e to the power x common, we get x square plus 2x minus 3. Now we equate this to 0. Remember, f dash x, we will put 0 to find out the interval points. Now we have this should be 0. Now this is what? A quadratic equation. How do we solve a quadratic equation? Let me show you. So e to the power x, this can be written as x square plus 3x minus 3. Right? Now take out common. So we have x plus 3 into x minus 1 into x plus 3. So x plus 3 common, we will get e to the power x into x plus 3 into x minus 1 equals to 0. This implies that x is equal to minus 3 or plus 1, right? If this is 0, x is plus 1. If this is 0, x is minus 3. This cannot be 0. So, minus 3 or 1. Now, I will tell you a shortcut method. What you have to do is, you take the number line, you plot these points. First, you will start from minus infinity. Then you will have minus 3. Then you will have 1. And then you will have plus infinity. This will be your number line. Negative number on the left hand side, positive number on the right hand side. Now simply what you do, you put alternative sign, plus, minus, like that. Now you check, what are they asking? They are asking decreasing function. Decreasing is minus, f dash x is negative. So it is between which interval? Decreasing between minus 3 to 1. This is your answer. Always remember, this is wavy curve method. Just plot the points like this, minus 3, 1 and infinity. This is positive, negative. Now, since they are asking decreasing, decreasing means negative. Where are you getting negative? Between minus 3 to 1. That is your answer. If they are asking increasing, it will be between this to this, increasing. That's your answer. Got it? Okay. So, increasing, decreasing function, you will get questions like this. Now, let's come to most important two topics, maxima, minima, tangent, normal. Every year you will have question from maxima, minima, tangent, normal, maxima, minima, tangent, normal, and they are super easy. Okay. First, you should know how to find out critical points. Now, what are critical points? They are the points at which your function becomes maximum or minimum. How you find that? You first find f dash of x. Okay. Now, you check if f dash of c is equal to 0 for which point. Now, suppose you will put f dash of x equal to 0 and you get point C1, C2, C3, that at this point my f dash x is coming 0. Those points are called as critical points. Okay. Now, let's understand maxima, minima. Local maxima, local minima, global maxima, global minima. Now, what is maxima, minima? Suppose this is a function fx. Now, fx will have a peak value and it will have a valley. Again, it will have a peak. Again, it will have a valley. Okay. So, this point, this peak is called as local maxima. These points are called as local minima. That they are least. Then after that it is increasing. Then it is reaching a least value. Then it is increasing. So local maxima, local minima. They are like class toppers and class last toppers. Like who come first from last. Okay. So they are local maxima and local minima. How you check whether it is a local maxima or a local minima? First, if you have a curve y is equal to fx, then at point x is equal to c, it is called as a local maxima if at fc you have value greater than f of c plus h greater than f of c minus h. That means at this point you have the maximum value. Greater than this, you will have smaller than you. Less than this, you will have smaller than you. For example, here, you have maximum value. Smaller than this, it will be a smaller value. Greater than this, again a smaller value. So, that's why it is a local maxima. Similarly, y is equal to fx will be minima at x is equal to c when the value is smaller than f of c plus h, also smaller than f of c minus h. Means it is smaller than the neighbors. Here, from here also it is the smallest. From here also it is the smallest. So it is local minima. Now this is just concept. Questions will not come from here. Question will come from here. How to find local maxima and local minima. Okay, let's check. The method is very simple. First, you find out the critical and the stationary point. How? There is a function fx. You find out f dash of x. You put f dash of x equals to 0. Put f dash of x equals to 0 and get x1, x2, x3. All the points where this function is becoming 0. Okay. After that, you check that at which point. No. After that, basically, you will find second order derivative, that is f double dash of x. First, you have find out f dash of x. Okay, so this is step number 1. This is step number 2. Find the critical points. Let me name it as C1, C2, C3. That will be easier for you. C1, C2, C3. Then you find out f double dash of x. Okay. Then you check if f double dash of x is greater than 0, then it is local minima. Remember, greater than minima. People get confused that if it is coming greater than, it should be maximum. No, it will be minima. If f double dash c is less than 0, it is local maxima. And if it is equal to 0, it is inflection point. Remember this word, inflection point. Direct question comes from this topic. So remember, what is inflection point? The point at which f double dash c is equal to 0. How you get that point? But you get that point from f dash x. Now, if you are not understanding all this, don't worry. Let's do previous year questions. You will understand how the question will come. Okay. See, direct question has come in 2017 question paper. A point of inflection point for this curve is what? How you will find out? First, this is f of x. You find out f dash of x. F dash of x is, f of x is given x cube, 6x square, 12x plus 50. You find f dash of x. You derive it. X cube derivation, 3x square. Then x square is 2x. So 6 2s are 12x. 12x differentiation is 12. 50 differentiation is 0. So you get 3x square minus 12x plus 12. Now you put this equal to 0. Why you put this equal to 0? Because you want C1, C2, C3, whatever critical points are there. Okay. Now here I can take 3 common. So if I take 3 common, I get x square 4x plus 3 equals to 0. So x square minus 4x plus 3 equals to 0. Now if I simplify this, x square minus 3x minus x plus 3 is equal to 0. X common, x minus 3 minus 1 common, x minus 3. I am just solving a quadratic equation. So here I get x minus 3 into x minus 1 equals to 0. This implies that x minus 3 and x minus 1 is 0. This implies x is equal to 1 or x is equal to 3. This is my critical point, but my answer is not over yet. In the question they are asking what is the inflection point. So I have 2 points. One point is x is equal to 1. Another point is, should I get 2 here? 3x cube is 3x square. This is 12x. Oh, my bad. This will be 4 here. Sorry. This will be 4. 3 4s are 12. Now why have I written 3? Let me solve it again. Our inflection point will change because of this. Okay. Here 4 will come. So this is basically, if we solve this, I will get x square, then minus 2x and 2x. Yeah. Plus 4 equals to 0. So I get x common, x minus 2, then again minus 2 common, x minus 2 equals to 0. So I get x minus 2 into x minus 2 equals to 0. Okay, so I am getting only a single inflection point. So I am getting x is equal to 2 or x is equal to 2. Both the points are same only. Now what will I check? I will just check if f dash x is 0 or not. Okay. Now we have to find out f double dash of x. So what will be f double dash of x? You derive this function. You have to derive this function. So it will be 3 2s are 6x and minus 12. Now at this point you put x is equal to 2 because my inflection point is coming 2. So I will just put 6 into 2 minus 12 is 0. Yes, f double dash of 2 is 0. That means x is equal to 2 is the inflection point. Just now we have seen what is inflection point? The point at which f double dash of x is 0. This is this is not writing x minus 12. This is, wait, I don't know what happened. Okay, f double dash of x is 6x minus 12. So we put here 6 into 2 minus 12, it equals to 0. So f double dash of 2 is 0. This implies that x is equal to 2 is the inflection point. Okay, very similar question. Find local minima value for this function. How you find local minima? Local minima should have f double dash of x greater than 0, right? Then only it will be minimum. Now let's find out f double dash of x. First, f of x is given, there is space. F of x is given x square minus x. So f dash of x will be 2x minus 1. Now this should be equal to 0. So if this is 0, then x will be equal to 1 by 2. So I am getting x is equal to 1 by 2. Now let's find out f double dash of x. F double dash of x will be 2. Hai na? If you derive this, You get 2. Now 2 is greater than 0. Therefore, x is equal to 1 by 2 is local minima. At this point, you are getting local minima because f double dash of x is greater than 0. But in the question, they are not asking the point of local minima. They are asking minimum value of the function. So now you have got that what should be the value of x. Now they are asking what should be the value of my function at x is equal to 1 by 2. So simply f of 1 by 2 you will find out. So f of 1 by 2 will be 1 by 2 whole square minus 1 by 2. So 1 by 4 minus 1 by 2 is minus 1 by 4. This should be your answer. Yeah, minus 1 by 4. Understood? Now, let's learn about global maxima or global minima. Now, what is global maxima or global minima? Very simple concept. See, this is a local maxima. Again, this is a local maxima. Again, this is a local maxima. That again, they are maximum then minimum, maximum then minimum, maximum then minimum. So, they are local maxima. Now, what is global maxima? Global maxima is like state topper. Local maxima is the class topper, but global maxima is the state topper. Now, who is the state topper in KEAM exam? So, if you observe point A, point B, point C. Point B is greater than point A and it is also greater than point C. That means this is global maxima. It is maxima of all of them. So, that is global maxima. Simple concept. So, what is a global maxima? If you have maxima value for the function, like you have all the local maxima, so you compare out of all the local maxima which is the maximum value. Similarly, what is global minima? Out of all the local minima which is the minimum value, that will be like global minima. Simple concept. Okay, let's do some more PYQs based on this concept. Number 1. Now this is a very interesting question. Easy, but look how difficult it looks. It looks like, oh my god, what should I do? I am not able to understand anything. It is saying P, Q, A, Fx, what? Don't worry. Simply read the question. They have given you Fx. Okay. They are telling that minimum of the function is attained at point Q. Maximum of the function is attained at point P, and P and Q are related to each other. Then what is A? First, we should find out what is minimum of function, what is maximum of function. Simple. That nothing else. First, that I will do. So, step number 1, f of x is 2x cube 9ax square 12a square x plus 1. Then I will find f dash of x. F dash of x is 3 2s are 6x square. 9 2s are 18ax. 12 2s are 12a square. Now I will also find out f double dash of x. 6 2s are 12x minus 18a. So this is f double dash of x. Clear? Now till here we are clear. Now let's do one thing. We will take f dash of x equals to 0. Let's put this as 0 to get my critical points. Okay. So 6x square 18ax plus 12a square is equal to 0. Now here 6 is taken out common. So x square 6 3s are 18, 6 2s are 12. 2. A square is equal to 0. Now this is a quadratic equation. So I will just solve it like a quadratic equation. So x square minus 3ax plus 2a square equals to 0. So x square minus 2ax and minus ax plus 2a square is equal to 0. X common, x minus 2a, then minus a common, x minus 2a equals to 0. So x minus a into x minus 2a is 0. This implies that x is equal to a, x is equal to 2a. These are my critical points. X is equal to a, x is equal to 2a. Now what we will do? Now we will take f double dash of x. Now f double dash of x is 12x minus 18a. Let's find out f double dash of a and 2a. At both the point we will check the value. F double dash of a is 12 into a minus 18a. 12a minus 18a is minus 6a, less than 0. F double dash of 2a is 12 into 2a minus 18a. So 12 to the 24, 24 minus 18 is plus 6a. This is greater than 0. Less than 0, maxima. Greater than 0, minima. Now I have got maxima, I have got minima, but in the question they have given, minima is at point Q. That means 2a is equal to Q. Next they have given maxima is at point P. That means A is point P because maxima is at point A. Now in the question they have given P cube is equal to Q. So just put P cube is equal to Q. P cube is A cube is equal to 2A. A square cube cancel. A square is equal to 2. This implies that A is equal to square root of 2. This is your answer. A is equal to square root of 2. So what we did? See, first you find, I will tell you step by step once again. First you find f dash of x. Then you find f double dash of x. Then you put f dash of x equals to 0 and you point x values. At this x value you check f double dash of x is less than 0 or greater than 0. For less than 0 it is maxima, for greater than 0 it is minima. In the question they have already given that maxima point is P, minima point is Q. Now they have also given relationship between them. So using the relationship we have got the value of A, that is root 2. In the question they are asking the value of A, that is root 2. Okay, next question. The maxima and minima of the function occur at what? See, direct maxima minima question, direct questions. Same method. This is f of x, step number 1, f dash of x. F dash of x is 3 2s are 6x square, 5 15 2s are 30x plus 36. Put this equals to 0. Now 6 taken out common, x square, 6 5s are 30, 6 6 are 36 is equal to 0. So we will simplify quadratic equation x square and minus 6x plus 6 is equal to, no. We will get minus 3x minus 2x plus 6 is equal to 0. Yeah. So we have x common, x minus 3, minus 2 common, x minus 3 equals to 0. So x minus 2, x minus 3 is equal to 0. So x is equal to 2, x is equal to 3. We have got 2 points. Let's check which is maxima, which is minima. F double dash of x will tell. What is f double dash of x? Derive this. 6 2s are 12x minus 30. 12x minus 30. Now our points are 2 and 3. So f double dash of 2 is 12 2s are 24 minus 30. So this is 24 minus 30 is less than 0. Negative value. See what is 24 minus 30? Minus 6 less than 0. F double dash of 3 at x is equal to 3. We have x is equal to 2, x is equal to 3, our critical points, right? So 12 into 3 minus 30. 36 minus 30 is plus 6. Plus 6 is greater than 0. So this is maxima, this is minima, right? So maxima is 2, minima is 3. So your answer is 2, 3. Simple. Don't write 3, 2. First maxima, then minima. Maxima is 2, minima is 3. So 2 comma 3 will be right answer. 3 comma 2 will not be right answer. Okay. Wait. Yeah. Last topic of this chapter, super easy topic, and this is asked literally every year 1 or 2 question. Every year 1 or 2 question. Super easy topic. Directly you can solve this. Okay, very easy. How to find equation of tangent and normal of a line. Now, step number 1. The equation of any line is written how? So you basically write equation of any line as y minus y naught is equal to slope. This is called as slope into x minus x naught. Now what is x naught y naught? It is a point on the line. So suppose you have a line, then there is a point which is x naught y naught. It can be anything. It can be 1 2, it can be 2 4, it can be anything. It's just a point on the line having slope m. Now, if you want to find out tangent of this line, what is the tangent of this line? So, tangent will also have similar equation, but tangent will have a different slope. How you find out slope of a tangent? So, slope of a tangent is dy by dx of the function, that is f dash of x. So basically बच्चों, for a tangent, slope is dy by dx, that is f dash of x at x naught y naught, whatever the points are given. Okay, so how you will write equation of the tangent? Equation of the tangent will be y minus y naught is equal to f dash of x into x minus x naught. Similarly, if you want to find out normal, now normal is what? It is perpendicular to tangent. If this is your tangent, this is your normal. So, slope of normal will be minus 1 upon f dash of x at x is equal to x naught. So, f dash of x is slope of tangent, minus 1 upon f dash of x is slope of normal. So, the equation of normal will be y minus y naught slope into x minus x naught. Okay, let's do some questions asked in the previous year question paper. First, the equation of normal to this curve at point x is equal to 1 is what? Let's find out. First, we will find out f dash of x. Now, f of x is 2 upon x square. That means 2 into x to the power minus 2. Let's differentiate that. We get 2 into minus 2 into x to the power minus 3. So, we get basically here minus 4 upon x to the power 3. But in the question they have given x is equal to 1. So, if we put x is equal to 1, we get 1 cube, that is minus 4. So, this is slope of the tangent, right? What is this? Slope of, sorry, not tangent, slope of the normal. Oh, my bad. This is not slope of the normal. Slope will be reciprocal of this. This is not slope of the normal. We have find f dash of x. Now, slope is equal to minus 1 upon f dash of x. So, minus 1 upon minus 4, it will be 1 upon 4. Now, this is the slope of the normal. Got it? Now, we find out equation of the normal. Equation of the normal is y minus y naught is equal to slope into x minus x naught. Now, what is x naught here? What is x naught? So, this is basically x naught. It is given 1. But what is y naught? We get it from here. Now, y naught will be equal to 2 upon x naught whole square. So, 2 upon 1 whole square is 2. So, y naught is 2. Now, put it here. Y minus 2 is equal to 1 by 4 into x minus 1. Cross multiply 4y, 4 to the 8, x minus 1. 4y minus x minus 7 is equal to 0. This is the equation of the normal. 4y minus x minus 7. 4y minus x minus 7. Answer. Okay. Let's do tangent also. Again, this is a KEAM PYQ only. Direct question. Equation of the tangent for this line at x is equal to 1. So this is f of x. Now f of x is minus 2x square plus 3. So f dash of x is 2 2s are 4x. Now f dash at point 1 will be minus 4 into 1 is equal to minus 4. This is slope of the tangent. We have got the slope. Now after you have the slope, you have x naught. This is x naught. But where is y naught? Let's find out y naught also. So this is slope. Fine. Now y naught is equal to minus 2 x naught whole square plus 3. X is given 1. So minus 2 1 square plus 3. So this will be 3 minus 2 is equal to 1. Y naught is coming 1. Now what is the equation of the line? Y minus y naught is equal to slope into x minus x naught. So y minus 1 is equal to minus 4 into x minus 1. So y minus 1 minus 4x is equal to minus 4x plus 4. So we have y plus 4x minus 5 is equal to 0. So my equation is coming y plus 4x minus 5 is equal to 0. Let's see. Yeah, correct. So this is y plus 4x minus 5 is equal to 0. Same, you write it like this or like this. Same thing. So you got the answer. See how simple is equation of tangent and normal, right? Let's do two more questions. Again, this is a KEAM PYQ only. The equation of normal to this curve at this point. Such a direct question. How direct it is. See, this is x naught, y naught. This is f of x. Normal is asked. First step, f dash of x is 2x plus 2. Oh, one twist is there. See here, the equation is not given in the form of y is equal to fx. So first you have to get it in the form of y is equal to fx. So it is given x square plus 2x minus 3y plus 3 is equal to 0. Put y on the right hand side. X square plus 2x plus 3 is equal to 3y. Now divide by 3. X square by 3, 2x by 3, 3 by 3 is equal to y. Now you can find out y dash, f dash x. So f dash of x will be, now you differentiate this. 2x by 3 plus 2 by 3 at x is equal to 1. So f dash at point 1 is 2 by 3 plus 2 by 3. This is 4 by 3. So f dash at point 1 is 4 by 3. But this is not the slope. This is not slope. Normal is given. Normal. For normal, the slope is, slope of a normal is minus 1 upon f dash of x. So it will be minus 1 upon 4 by 3. So it will be minus 3 by 4, not 4 by 3. Now you find out the equation. Y minus y naught is slope into x minus x naught. Y minus 2 minus 3 by 4, x minus 1. Solve it. So you get 4y, 4 2s are 8, 3x, 3 1s are 3. So 4y plus 3x and minus 8 minus 3 is minus 11 equals to 0. Which option? First option. Answer. So first you should get f dash of x. Then you should get minus 1 upon f dash of x because that is slope of normal. For tangent, directly f dash of x. For normal, minus 1 upon f dash of x and then you put the values in the equation. Got the answer. Now, one twisted question. Same topic, very similar topic, just the question is twisted. Let's see what the question is saying. It is saying that fx is given root x. Okay. Then it is saying that my point C belongs to 4 and 16. Many students think what? That C is equal to 4 and 16. So this is X, this is Y. No, it belongs to 4 and 16 means that is the limit that between 4 and 16 you will get point C. So don't think that it is X and Y. Now read the question. Point C is such that tangent of line to the graph at x is equal to C is parallel to the chord joining these 2 points, then what should be the value of C? First, if your tangent is parallel to this line having 16, 4 and 4, 2, then remember, if 2 lines are parallel, then they have same slope. If 2 lines are parallel, they have same slope. How you calculate slope? Very simple. Slope is equal to y2 minus y1 upon x2 minus x1. So it will be 4 minus 2 upon 16 minus 4. 4 minus 2, 2. 16 minus 4, 12. 2 6 are 12, so it is 1 by 6. So your slope of the tangent is 1 by 6. But in the question, they are not asking equation of tangent. They are asking at what value of x the slope of the tangent is 1 by 6. So let's find out slope of tangent. Slope is equal to f dash of x. F dash of x is derivation of root x. Derivation of root x is 1 upon 2 root x. Now this implies that 1 upon 2 root x is equal to 1 by 6. So find out value of root x. 2 3s are 6. Root x is equal to 3. So x is equal to 3 3s are 9. So this implies that C is equal to 9. Why? Because at this point, slope is 1 by 6. Because in the question they are saying, at point C, the slope is coming this. Parallel to this. Parallel to this means 1 by 6. Slope of root x. How you will find slope of root x? F dash of x. So first we find f dash of x, then we find slope, then we equate them both to get value of C. So your answer is 9. Alright. So guys, that was all about this complete chapter. I have shown you each and every topic and I have shown you how direct the questions are from this topic. You don't have to do any extra logic, any extra formula. Direct formula based each and every question from this chapter comes, especially increasing, decreasing, maxima, minima, tangent, normal. And tangent normal is mostly asked. Alright, so if you have watched this video, then it is enough for the preparation of application of derivatives. No need to watch anything else, no need to learn anything else. Alright, thank you for watching the video. You will get notes of this lecture on our Telegram channel, so do join that. Link is in the description. If you enjoyed today's video, please drop a comment and drop a heart in the comment section. Like the video and share it with your friends. It gives us a lot of boost up so that we bring more and more sessions for you. Okay, very soon I will bring some tips and tricks, shortcut methods to score good marks in maths KEAM exams. Stay tuned. Thank you for watching. See you in the next class. Bye bye.